At the center of our galaxy, where the light of stars vanishes into a whirlpool of darkness, there is something powerful. A place no one has ever seen with their own eyes, yet it shapes the entire movement of the Milky Way. There, in the galaxy's hidden heart, lies a giant, not a planet, not a star. Something far denser, far stranger. This is the core of the Milky Way, a point where gravity is so intense, even light can't escape. But what really lies there? And if we got close, what would we see? Today you'll travel across the galaxy to uncover one of the universe's most guarded secrets. Get ready to face the heart of the Milky Way. The Milky Way is a massive spiral galaxy. If we could view it from the outside, it would look like a flattened disk with spiral arms full of stars, gas, and dust. But what most people don't know is that in the middle of all this vastness, there's a fixed point, a gravitational anchor so powerful that every one of the galaxy's hundreds of billions of stars, including our sun, orbits around it. But where exactly is this center? And how do we even locate it if we can't step outside the galaxy to look back? The answer lies in modern astronomy and a lot of patience. Using infrared and radio wave telescopes, scientists studied the motion of stars near the galactic core. What they found was extraordinary. Stars moving in tight, rapid, elliptical orbits, as if circling an invisible object. Something incredibly compact, with a mass over 4 million times that of the Sun. That object is called Sagittarius A, a supermassive black hole. It sits about 27,000 light-years from Earth, in the direction of the Sagittarius constellation. But we can't see it directly. The black hole emits no light. What we do see are its effects. Matter spiraling in at tremendous speed, glowing intensely as it's torn apart before vanishing into the dark. So how are we so sure it's there? In 2022, the Event Horizon Telescope captured the first actual image of its surroundings. A glowing ring of light warped by gravity, a shadow encircled by scorching gas. It was visual proof of what decades of calculations had already predicted. The center of the Milky Way isn't just a theory. It's real, it's active, and it's pulling on us. Always. At the heart of our galaxy, hidden behind thick clouds of cosmic dust and bathed in waves of radiation, lies one of the most extreme places in the known universe, the center of the Milky Way. Most people imagine the galactic center as a relatively empty region full of stars, but reality is far more chaotic and fascinating. There sits Sagittarius A, the supermassive black hole we've already mentioned. But surrounding it is anything but calm. Picture a stellar cluster tens of times denser than anything near our sun. Young, hot stars crowding alongside old, dying ones. Superheated gas, unstable magnetic fields, shock waves, X-ray bursts, and at the core of it all, a black hole warping space and time itself. The galactic core is dominated by a nuclear star cluster, millions of stars packed into a region just a few light-years wide. Many of these stars race at incredible speeds, locked in a frenzied dance around the invisible abyss. This environment is wildly dynamic. Stars are born and destroyed rapidly. Supernovae are more common. Binary systems get too close to the black hole and are slowly devoured. But what makes this region even more fascinating is what we can't see. Evidence suggests the center is rich in dark matter, an invisible substance that doesn't interact with light but exerts gravitational pull. It may be helping stabilize the galactic core, or slowly falling into the black hole, influencing everything around it. The region is also one of the brightest sources of gamma rays in the Milky Way. These ultra-high-energy rays pierce through matter as if it were nothing. We don't fully know why. Some say it's due to dark matter collisions. Others blame extreme neutron stars and pulsars. Thanks to telescopes like Chandra, the Very Large Telescope, and the Event Horizon Telescope, we've captured stunning detail around Sagittarius A. We've tracked stars like S2, racing at 7,000 kilometers per second. It orbits the black hole every 16 years, a dance so precise, it let us test Einstein's general relativity with unprecedented accuracy. And in 2022, we saw the shadow of the black hole itself, a glowing ring warped by gravity around the event horizon. Yet mysteries remain. The galactic center regularly emits flares, brief outbursts of energy that last minutes to hours. We're not sure what causes them. Maybe it's in falling matter. Maybe it's magnetic interactions. Maybe something stranger. Studying the center of the Milky Way is like peering into the mind of a living galaxy. It's where we begin to understand how galaxies form, evolve, and die. Everything that happens there influences what happens out here, even 27,000 light-years away. Variations in the black hole's activity can, over time, shape the galaxy's gas, star formation, and even the sun's orbit. Knowing what's there isn't just scientific curiosity. It's about understanding the origin, balance, and fate of our place in the cosmos. The center of the Milky Way is like a cosmic heart, pulsing silently in the dark. It's far away, over 27,000 light-years from where we are. But make no mistake, what happens there echoes across the entire galaxy, as if every stellar atom is somehow tethered to that compact and turbulent region. It's a dense, violent, unstable realm, dominated by forces that defy everyday logic. And even without realizing it, we are affected by it. At the core lies Sagittarius A, the supermassive black hole that acts as the galaxy's gravitational anchor. It holds the mass of over 4 million suns packed into a space smaller than Mercury's orbit. This invisible beast maintains the structural cohesion of the Milky Way, not with chains or ropes, but with gravity, the silent language of the cosmos. Thanks to its presence, the spiral arms of the galaxy rotate in a relatively organized fashion. Without this massive center, the galaxy's orbital balance would slowly unravel over billions of years. Stars would lose the harmony that holds the spiral together, like grains of sand thrown into the wind. But the center's influence extends far beyond structure. It's also an energetic epicenter. Observations across the electromagnetic spectrum reveal that the Milky Way's core is anything but passive. On the contrary, it emits jets, bubbles, shock waves, and streams of charged particles that shoot through vast stretches of interstellar space. One of the most striking examples is the Fermi bubbles, discovered in 2010. These giant lobes stretch over 25,000 light-years above and below the galactic plane, like balloons inflated by a past cosmic explosion. They contain high-energy radiation, likely triggered by a hyperactive phase of the central black hole, an ancient outburst that left scars on the body of the galaxy. This energy doesn't dissipate harmlessly. When the galactic center unleashes radiation or matter, it can alter the magnetic fields around it, push interstellar gas clouds outward, and even trigger gravitational shocks that interfere with the birth of new stars. In other words, the Milky Way's center, though relatively quiet today, has the power to sculpt the galaxy's stellar architecture for millennia. A sufficiently strong cosmic ray emission can accelerate particles to near-light speeds, shooting them through space like invisible bullets that collide with atoms and molecules, even in our own solar system. You might be wondering, are we really affected, even from so far away? The answer is yes, and no. We reside in the Orion Arm, a minor spur between the galaxy's larger arms, and we appear to be in a safe zone. But safety is relative. Over hundreds of millions of years, the solar system doesn't stay still. It orbits the galactic center on a slow, undulating path. It rises and dips through the galactic plane, nudged by variations in the Milky Way's density, and many of those variations originate, directly or indirectly, from the core. These oscillations have consequences. When the solar system passes through denser regions of the galaxy, it can disturb the Oort cloud, a vast spherical shell of icy comets at the edge of our system. That disturbance could send a wave of comets inward, increasing the chances of impacts on Earth. Some theories even link these periodic crossings with mass extinction events throughout our planet's history. A subtle gravitational shift that began tens of thousands of years ago in the galactic core could ultimately lead, millions of years later, to the fall of an asteroid here. The galactic center is also a source of gravitational waves. While most of the waves we detect today come from black hole or neutron star collisions elsewhere, It's likely that some events in our own galaxy's core emit them too. We don't yet have the sensitivity to detect all of these signals, but astrophysicists are convinced that Sagittarius A is not silent. It may be a factory of invisible ripples in spacetime. And then there's the role of the galactic center in dark matter distribution. Current models suggest this invisible matter, which makes up most of the Milky Way's mass, is concentrated in a halo around the galaxy, but with higher density near the core. That gravitational mass affects the orbital speed of stars in the outer regions, including our Sun. In short, the Sun's current motion, its velocity, orbit, and stability is influenced by dark matter clustering near the galactic center. If that mass shifts even slightly, the solar system's orbit could change, and with it, Earth's climate, magnetic field, exposure to cosmic radiation, factors that directly influence life. We're only beginning to understand this. Modern astrophysics is revealing that the galactic center is less a fixed point and more a dynamic engine, full of layers and interactions. There are gas flows spinning at absurd speeds, twisted magnetic fields, and hypervelocity stars being flung from the core like gravitational projectiles. Even in its current calm, Sagittarius A continues to feed. It still consumes matter, and it could awaken, like a sleeping beast. If a new phase of intense activity began, as has happened in the past, the effects would be felt across the Milky Way. The first signs would arrive as radiation bursts, particle storms, gravitational disturbances, and perhaps the birth of a new generation of stars near the center, fueled by the newly released energy. In short, the galactic center is the dynamic axis of a living structure. It doesn't just define the shape of the galaxy, it influences its mood, rhythm, and reactions. What happens there echoes here. Earth may seem like a tiny speck on the galactic fringe, but it is subtly in sync with that distant heart. And that connection reminds us of something profound. In the universe, everything is linked. Even us. There's something about the center of our galaxy that puzzles even the most experienced scientists. What else could be lurking there? We know that Sagittarius A is a supermassive black hole, but that might just be the centerpiece of a much more complex and mysterious structure. Recent studies suggest there may be a swarm of smaller black holes orbiting Sagittarius A, like a kind of gravitational hive. They would be invisible to the naked eye, but detectable through their influence on nearby stars. This creates a region where gravity is so extreme and chaotic that the laws of physics as we know them begin to break down. In addition, scientists are investigating signals that could indicate a higher concentration of dark matter in the galactic core. If confirmed, this would turn the heart of the Milky Way into a natural laboratory to study one of the greatest mysteries in the universe. And some even wonder, could exotic structures like wormholes or even advanced civilizations be hiding within the gravitational chaos of the galactic core? While there's no concrete evidence, the center of the galaxy remains one of the best places to search for phenomena that challenge our current understanding of reality. At the heart of the Milky Way, it's not just the black hole that steals the spotlight. There's a silent, mesmerizing performance happening there. Stars that dance. Literally. They orbit the galactic center in orbits so fast and elliptical that they challenge our understanding of cosmic stability. These are called S-stars, and the most famous of them is S2. It completes an orbit around the central black hole in just 16 years, an astonishing speed, considering it's orbiting something with 4 million times the mass of the Sun. During its closest approach, S2 travels at over 5,000 kilometers per second. But what makes these stars truly important isn't just their speed, it's what they reveal. Thanks to them, astronomers have been able to measure the mass of Sagittarius A with precision and confirm effects predicted by Einstein's general theory of relativity, such as gravitational redshift. These stars act like cosmic clocks, helping us understand how extreme gravity distorts spacetime. Even more, by studying disturbances in their orbits, scientists are trying to detect signs of dark matter, hidden planets, and even local gravitational waves. And here's the unsolved puzzle. How did these stars get so close to the black hole without being torn apart? They're not supposed to be there. The environment at the galactic center is extremely hostile. with intense gravitational tides and high radiation levels. This raises the possibility that they may have formed elsewhere and were pulled in by some unknown mechanism. We're looking at stars that defy everything we know about star formation, orbital mechanics, and cosmic survival. Every time we observe them, it's like the universe is whispering, "There's still so much you don't understand." If you enjoyed this content, don't forget to like and subscribe for more videos about the universe.